Have you ever needed to create different versions of the same math-based problems? Maybe to give students additional practice with fresh data sets? Perhaps to maintain academic integrity and guard against cheating? How about to show multiple representations of the same concept? This video demonstrates 10 ways an activity can vary so that each user truly has a unique version of the problem. The result is the ultimate algorithmic problem in Excel. This is an accounting problem created in Excel. It requires users to solve for 4 unknown amounts. It's often a good idea for each user to have a different version of the problem. Here are 10 elements that can vary so that the information provided and the layout of the problem are unique. Each version is truly an original. The first element that varies is the company name. The company name that appears in the first line of the data given and in the heading on the balance sheet varies with each iteration. All 3 words in the company name may differ from version to version. The second element that changes is the date. The month that appears in the first line of the data given, in the beginning retained earnings balance, and on the balance sheet varies with each version. The last day of the month on the balance sheet is correct for the respective month. So here we have February 28th, June 30th, October 31st. So the ending day of the month does match the respective month. The most obvious element that changes with algorithmically generated data is the amounts. All values given in the activity are randomized, so they result in realistic numbers and outcomes. The correct answers shown in the yellow entry cells differ for all versions based on the different amounts in red that are given. The amounts fall within the same reasonable range for all versions, so they are similar in difficulty level and format. Notice that the last digit in all values is 0, which is intentional by design, so all versions are consistent. A unique version identification number appears at the top of each iteration of the activity. This identifier is a clear visual cue to student users that their assignment is not the same as any other student's version. Now we'll look at some really unique features that make the Excel problem vary. First, the order of the data given is different for each version. In this activity, 4 amounts are required to solve for the retained earnings unknown on the balance sheet: revenue, expenses, beginning retained earnings balance, and dividends. The order in which these 4 amounts appear varies with each version to mix up the appearance of the activity. Next, the answer entry cells vary. There are 4 unknowns to solve for in this activity. Regardless of the version, retained earnings, total assets, and total liabilities and stockholders' equity are unknowns that require answers in yellow entry boxes. For each version, however, amounts are given for 3 of the following 4 accounts: cash, accounts receivable, equipment, and accounts payable. To the right of the 4th of these accounts is a yellow entry box. The placement of the 4th yellow entry cell varies with each iteration. So as you can see from the graphic, there are 4 red arrows pointing to the possible cells that might be used as a yellow entry cell, and they vary with each iteration. So right now it's equipment, next accounts receivable, next time it's cash, and so forth. It varies each time. The contiguous columns and/or rows that contain data or entry cells for the activity vary with each iteration. There may be hidden columns and/or rows that contain no data or entry cells. This design promotes the need for different formulas for different versions. So as you can see here, we have column C and column E. Column D is hidden. We have row 17 and to row 19, so column 18 is hidden. And this varies by version. The activity is randomly generated in two different layouts. The vertical format lists assets, liabilities, and stockholders' equity above one another in one column. The horizontal format lists assets on the left side and liabilities and stockholders' equity on the right side. One of the most unique elements that varies is the position of the problem on the worksheet. The location of the activity on the worksheet varies with each iteration. The address at the top left cell on the page is different for each version, and this design promotes the need for different formulas for different versions. You can see that this version has a top left cell of G13. This different version has a top left cell of D6. The last element that varies is the design. The look of the activity can vary based on each iteration. Colors, fonts, borders, shading, and other design elements may differ. The unique appearance of an activity is a clear visual cue to student users that their assignment is not the same as any other student's version. And you can see that here's an alternative assignment, and it does look quite a bit different than the previous one. So here you have it all in terms of the elements that vary: the company names, dates, amounts, version ID numbers, the order of the data given, the various entry cells, hidden rows and/or columns, layouts, positions on worksheets, and design. And this second example shows you a horizontal balance sheet rather than vertical, and also shows you that there is a different starting cell at the top left of the screen. The result is the ultimate algorithmic problem in Excel. Thanks for watching.